Hi everyone. So we have a question that reads, find the Cartesian equation of the line or curve whose polar coordinate is r is equal to asec theta minus alpha. So let's zoom in solving it. So now the equation here is in polar form, okay? And so this is, when we say polar form, it's in terms of cos theta, okay, and sine theta. So, and they want us to express this polar form in a Cartesian form, okay, in a Cartesian form which is this way. Okay, so let me, okay, so Cartesian form is in terms of, that's x and then y, right? So here right now it is in terms of cos and sine, okay, so they want us to express it in terms of x and y. So how do we do that? So the equation here is r is equal to a sec theta minus alpha. Okay, so let's do this. Let's try to convert this in a normal form, in like kind of cos and sine. Okay, so this is sec theta, and trig identity, we know that when you have sec, okay, sec is equal to sec of anything, okay, of an angle is equal to 1 over cos, right? So in front of the sec, it was theta minus alpha. So it means in front of the cos, we'll put theta minus alpha. So let's substitute that here. Okay, so we'll say that rewriting the same equation, we have r is equal to a multiplying, a was multiplying this. So a will multiply 1 over, okay, so in place of sec is now 1 over cos, right? But is this is theta minus alpha. Okay, so we can be able to get the solution they want. Okay, so from here we can now rewrite the same thing here. When you have a, okay, when you have a multiplying b over c, the a is multiplying just the b, okay, so the numerator. So here a will multiply the 1. So we say that r is equal to, so the a multiplying 1 become a over, right, cos theta minus alpha. Okay, and so we've gotten another equation again with another kind of given here, which is when you have b, okay, when you have b, let me use a, okay, already I'm using, when you have a is equal to b over c. Okay, how do you work this? This a here is over 1. Okay, so we cross multiply by doing the c will multiply the a here, okay, to have, for us to have ac is equal to the equal to sign. Okay, the 1 will come and multiply the b here to have 1 times b, which is 1b, which is the same as b. So we apply the same ideology here. So we'll cross multiply here, right? We say that r into bracket, r will multiply this, so this will multiply the r, which is cos, oh my god, I should have done it, okay, so let me do this way, cos into bracket theta minus alpha, right? The equal to sign is there. We said the r is over 1, right? Any whole number is over 1, so that's is equal to a. Okay, the 1 times a is a. So from here, what do we do? uh this is an identity also, right? Can you remember this? A trig identity that says when you have cos cos a minus b, okay, this is equal to cos a, right, cos b, and because it's cos a minus b, it becomes positive sine a sine b, right? This is a trig identity we must all know. Okay, so instead of the a and b here is theta and alpha. So just we'll replace the the a by alpha, and then the b by the b by, we'll replace the a by theta and then the b by alpha, right? And so we get the same thing here just by replacing wherever we see a is alpha, wherever we see b is, wherever we see a is theta, and wherever we see b is alpha. Okay, theta alpha. So the same thing here. Let's substitute that value here. So we have that r. Okay, so that because this is, I'll put this in the bracket. I'll say into bracket. That's the first one here. Okay, cos now is theta, right? Cos theta cos alpha plus into bracket this now sine theta sine alpha, right? Sine alpha, just like here. Okay, and so we are saying that this is equal to the a. Okay, so what do we do from here? Okay, I will now enter the bracket, the this in the value outside. Okay, the variable outside. That's in a sense that when you have a multiplying into bracket b plus c, this is the same as a times b, which is ab, plus a times c, which is ac, right? So we apply the same ideology here. So we'll say that this is equal to r cos theta cos alpha, right? Plus the r will multiply this. The r just multiply this to get this. The r will multiply this to, which is r sine theta sine alpha, right? And this whole thing is equal to a. Okay, but let's remember, uh, in complex numbers, these are two givens we must know off head. Okay, we know that x is equal to r cos theta, okay, and y is equal to r sine theta. Okay, these are two given we must know off head. Okay, so this is the x is in the cos form, okay, and then the y is in the sine form. So x is equal to this. So from here we can now replace wherever we see r cos theta, we replace it by x, right? Wherever we see r cos theta, and wherever we see r sine theta, we replace it by y, right? So here it become, this becomes my x, okay? So that will be x cos alpha, right? Cos alpha plus, now r sine theta is y, plus y sine, when we take this one to be y, then this becomes sine alpha, right? This remains sine alpha. So is equal to, this is equal to a. And what we have done here is that we've been able to express, okay, what was in a polar form, okay, in x and y value. So the cos alpha and the sine alpha here are treated as constants, right? And so this is the Cartesian equation in x and y. Okay, so that's therefore x cos theta plus y sin theta is equal to a. And remember, when we say Cartesian form, that's x and y. Okay, that's the coordinate. And then also when we say that polar form, we have either, that's in complex numbers, we have cos as cos theta and then sine theta. Okay, so these are the points. But here is an equation they wanted. So this is the equation form. Thank you. Subscribe to my YouTube channel. Okay, subscribe to my channel and get to be able to know how to solve questions in a very easy way. Thank you.